Rockets are still the way and our means of getting our spacecraft into space, and it is a violent event. The worst thing that happens to a spacecraft happens at the very beginning of its existence.
5, 4, 3, 2, 1, 0. We have liftoff of the Falcon 9.
Vibration testing is the means that we have to test the launch vehicle environment that a spacecraft is exposed to on its way into space. And so what we do to expose it and test it to make sure that the spacecraft can handle that environment is to send it through a set of vibration tests to test that the structure of the spacecraft, the instruments, all the sensors and avionics on board can withstand the rigors of that chaotic and pretty violent launch event.
We use software both to design the spacecraft and then to analyze that design. We're testing it to see what the panel, the solar panel on the spacecraft wants to do naturally in the vibration test. Before we ever get to the vibe table, we want to make sure we understand where we think its peak response is going to be, what frequencies are going to cause it to resonate, and those frequencies we're very interested in, because when we get to the test and we have our accelerometers mounted on the panels, we'll want to see how closely our predictions in the design and in the analysis were, and then be able to correlate that model later on. Sometimes the reaction wheel will all of a sudden respond very strongly to that input, or the star tracker, depending on what frequency is being excited at the time. And it's really all about how that launch vehicle holds onto your spacecraft, and all of the energy coming from the rocket into that fixture that holds your spacecraft. That is the path by which the random vibration enters the spacecraft, and your model helps you analyze how that's supposed to go.
Because Arkyd 6 is a 6U CubeSat that is containerized inside of a deployer, we try to mimic the same type of boundary conditions that the spacecraft will be in during its flight on the ground. So in the vibration test, we use a test pod that represents that deployer as the boundary conditions for Arkyd 6 to sit within while it's being exposed to the vibration environment.
We transport the test fixture up to Sistema Technologies to do a vibration test at their facility. We mount it to a large plate that they have, and they have a large electrodynamic shaker, and all that is a giant motor that oscillates back and forth that then shakes the spacecraft with this random vibration signal that we give it. And in order to not just break it right away, we start at a very low level. So we have this random frequency signature, and then we amp up the amplitude of that signature run after run after run until we finally achieve the full-on rocket level input for the test. And all the time during that test, we're monitoring those sensors we placed, and we're looking at the data in between each run to say, you know, we're doing okay, or we might see a problem here, and then we have to understand what's going on and maybe do a little bit more real-time analysis. It's a scary thing to be in that test in the room very close to the test article. You have this emotional attachment to this thing that you're putting on the table, and you don't want it to break, and but you know the test you have is necessary, and you know you've done the analysis to prove that it's going to be okay. It's still a tense time because you don't want anything to happen. So when you're there and you hear that level of noise going into the spacecraft, and you hear the rattles and everything else in the spacecraft that you normally treat with kid gloves as you handle it, it's impressive and it's intimidating when you're standing next to it.